Dear students, good evening and a warm welcome to CSAT Made 2025 series, where we discuss the most exam specific questions and concepts from the angle of your CSAT paper of 25 year. I am Sachin Gopinath and our today's topic of discussion would be number system. And as I have told you multiple times before, number system, it is a very important topic from the angle of your CSAT paper always. So let's begin with the topic, and as always we will begin with basic level questions, understand the basic concepts, then gradually rise up to exam level questions. Okay, let's look at the first question now. This is your first question. One of the two positive integers p and q is even while the other is odd, not necessarily in that order. So p plus q can be even, p minus q is definitely odd. Which of the above statements is or are correct? Okay, what are they telling us? They are telling us that there are two integers p and q, both of them they happen to be positive integers. One of them is even and one of them is odd. We do not know which one is which, and they have given us two statements. The sum of them, it can be even, and the difference between them, it can be, no, it shall be odd. Okay, what is the concept behind this question? The concept behind this is simple. When you add or subtract two even numbers, the difference or the sum that you would get, it would always be an even number. Then when you add or subtract two odd numbers, once again the sum or the difference, that would be even number. So these two belong to one category. So even plus even or even minus even, this is, read this as plus or minus. Okay, so even plus even, it is even, even minus even, that is also even, odd plus odd, that is even, odd minus odd, that is also even. You need not memorize this actually, you can just imagine in your head, 2 plus 2, 4, 1 plus 1, 2. So if you add two odd integers, it is giving you an even integer, and if you add two even integers, that would give you a even integer again. Okay, and these two belong to one category because they give you a result of even number. However, when you add an even number and an odd number, or when you subtract one from another, the resultant would be odd number. And when you add an odd number to an even number or subtract this from this, again the resultant would be an odd number. So these two you can in your head you can categorize these two to be one category and these two to be another. Okay, and another thing you should know is when they give you can be, you shall try to prove it correct. If it is proven at least in one of the cases, then it is true. But when they give you definitely, it has to be true in all the cases. Do read these two statements and you will understand. A statement that says can be is true if what it says is true in at least a single instance. So you have to try to prove this true. P plus q can, when they say can be, you have to try to prove this true. If you can prove it for any number that you can imagine, then it will be right. But when the statement says definitely, a statement that says definitely is true only if what it says is true in all the instances. When something says definitely, try to disprove it. If you cannot disprove it, then it is true. But if you can disprove it in at least one instance, then it is wrong. Okay, that is the difference between can be and definitely. I think that is, I think you know it by common sense already. Okay. Now let's try to answer these ones. P plus q can be even. So one of them is even while the other is odd. Okay, whichever of them be, this would be an even plus odd, right? Then it would be even plus odd, or it would be odd plus even. We know that even plus odd or odd plus even, it always gives you odd number. It always gives you odd number. It can never be even. So in this case, statement 1 is wrong. Okay, let's look at the second one. P minus q, it is definitely odd. So one of them was even and the other is odd, whichever it may be. One of them is even and the other is odd, or this be even, this be even and this be odd, or this be odd and this be even. Then the resultant, it is always odd. So 2 minus 1, 1, or 5 minus 6, okay, that would be minus 1. Minus 1, it is also considered odd. Okay, even though number is negative, if it is divisible by 2, only then it is even. If it is not divisible by 2, then it is odd. So 6 minus 5, 1, odd. 5 minus 6, minus 1, that is also odd. So statement 2 statement 2 is true. It is definitely odd. P minus Q is always odd. So what would your answer be? Your answer would be 2 only. Okay. Now let's go to the next question. One of the two positive integers P and Q is even while the other is odd. Not necessarily in that order. 2P plus Q can be even. 2P minus Q, it is definitely odd. How is this different from the previous question? There you have P plus Q and P minus Q. Here you have 2P plus Q and 2P minus Q. Okay. Let's consider them. The concept behind this one is this: 2 into any number, be it even or odd, the resultant would always be even number. That is the concept based on which this question has been framed. Okay, let's imagine P to be, let's evaluate the first statement. To evaluate the first statement, let's imagine P to be even and Q to be odd. Let's imagine, take the numbers 1 and 2. Okay, let's imagine 2 into 2 plus 1. This would give you 5. So odd. Okay, so our condition did not satisfy it. However, it says can be, so we shall try to prove it true. If it can be proven true in just one instance, then it is true. Okay. Now we took P to be even and Q to be odd. It did not work out for us. Let's take P to be odd and Q to be even. 2 into 1 plus 2. This is odd, this is even. This will give you 2 plus 2, 4. Yes. So it is true in one instance. So it can be even. Yes. So our statement 1, it is true. Okay. Let's evaluate the second statement. 2P minus Q, it is definitely odd. Okay. Let's make P even and Q odd, and let's see. We will take simple numbers 1 and 2. They are the simplest, right? Yes. 2 into 2 minus 1, that would give you 4 minus 1, that is 3. It is definitely odd. Yes. Now let's make P odd and Q even. 2 into 1 minus 2, that would be 2 minus 2, this is 0. Okay, 0. It is neither it is neither odd nor even. However, in such instances we can consider it to be even. So that is also coming to be an even number. Also that is even. We will try other numbers. 2 into 3. If you are not convinced with 0 being an even number, in such instances we can take 0 to be even. However, if you are not convinced, let's just change the numbers. 2 into 3 minus 2. 2 into 3, that would be 6 minus 2, that would give you 4, and this happens to be an even number. But what does the question say? It is definitely odd. It is definitely odd? No, it is odd in some instances and even in other instances. So statement 2, it is not definitely true. So what would your answer be? Your answer would be option A, 1 only. Okay. Now you understood the basic concept of this topic. Let's go to advanced level questions. Let A, B, C, D, E, F, G, H, I and J be 10 positive integers, half of which are even while the rest are odd, not necessarily in that order. Consider the following: A minus B plus C minus D plus E minus F plus G minus H plus I minus J is definitely odd. 2A minus B plus 2C plus D minus 2E minus F plus 2G minus H minus 2I plus J can be even. Okay. Now this looks too lengthy to process. However, it is not as lengthy, it is not as tough as it looks. It is actually quite easy. We will just stick to the basics and apply our basic method, and we will get the answer to this. Okay. How? Let's evaluate the first statement first. Let's evaluate the first statement. Now there are 10 digits and 5 of them are even and 5 of them are odd, but we do not know which one is which. Okay. Which are the positive integers? A, C, E, G and I. Okay. So what do you have? You have A plus C plus E plus G plus I. Okay. Minus B, D, F, H and J minus B plus D plus F plus H and J. Okay, h and j. Okay, now they are telling us that this expression, it will be definitely odd. Okay, now we shall make all of these even and all of these odd, because that is what they are telling us. 5 of them are even and 5 of them are odd. Let's imagine these to be even. So if all the 5 integers are even plus even, that will give you even, and even plus even, that will give you even, and even plus even, that will give you even, and even plus even, that will give you even. Okay, if you do not understand, we shall substitute values for them. We shall give it 2 plus 2 plus 2 plus 2 plus 2. Okay, now we shall make them odd. 1 plus 1 plus 1 plus 1 plus 1. So this would be 10 minus, this would be 10 minus 5, which would be 5. It is odd. Okay, let's try another way. Let's make these ones odd and these ones even. Okay, that will be 1 plus 1 plus 1 plus 1 plus 1 minus 2 plus 2 plus 2 plus 2 plus 2. That would be 5 minus 10, that would give you minus 5. And I told you we will consider negative, we will classify negative integers also as even and odd based on if it is divisible by 2 or not. So option statement 1, it is holding, it is definitely odd, it is odd, and this is also odd. We can try some other combination. We can make 3 of them odd, 3 of them even. However, in all the instances, that will give you odd. I will tell you why. Read this these concepts. When you are doing either addition or subtraction between 2 even numbers or 2 odd numbers, or even and odd and even, the plus and minus and they are not contributing anything, right? If be it even plus odd or even minus odd, the resultant will be odd, and odd plus even or odd minus even, the resultant will be odd. Okay, in this instance what happens is, what happens is, so you can consider them to be 5 pairs of an odd number and an even number. For example, this is one pair, this is one pair, this is one pair, one pair, and one pair. So have 5 pairs, even odd, even odd, even odd, even odd, even odd. Ignore the minus sign, they are just there to confuse you. If it is plus or if it is minus, it doesn't make us any difference, because see here, be it plus or be it minus, the resultant remains same. Okay, so let's imagine that they are all plus, no problem, they are all plus, and we have 5 pairs for every. It need not be 1 and B, it can be 1 and C, it can be B and J, anything. For every one even integer, you have one odd integer. So you are doing either addition or subtraction between an odd integer and an even integer, and then the resultant, it would always be odd. Okay, so you have 5 pairs of even comma odd, and the resultant of each of them will be odd, and the resultant of each of them would be odd. So now you have, let's say you simplified this one to be x, and let's say you simplified this to be p, q, r, s and t. Okay, now you have 5 odd integers with you. After simplifying a pair of even integer and an odd integer, then you together what you will have? You will have one odd integer, and such you will have 5 odd integers. Okay, this will give you 5 odd integers. Okay, and with 5 odd integers, let's group them again. Let's group them how? Let's pair them up. You have 5 odd integers, they can be 1, 3, 5, 7 and 9. group these two and group these two. Then you will have, this one will give you a result of even, because odd integer plus or minus odd integer, that will give you even, and this one will give you again even, odd integer plus or minus odd integer, that will give you even, and together after adding them they will give you an even even resultant, because this would be 4 and this would be 12, and together they will give you 16, and after that go for the remaining one odd odd integer, that will give you, ultimately it will give you an odd resultant. So this expression, 5 of them being even integers and 5 of them being odd integers, the resultant, it will always be odd. So statement 1, it is true. Okay. Now let's evaluate the second one. 2a minus b plus 2c plus d minus 2e minus f plus 2g minus h minus 2i plus j. And as I told you, this minus signs, they are just confusing us. We will just imagine them to be plus, because plus or minus does not matter to us while considering the resultant to be, while evaluating if the resultant is even or odd. Okay. Now let's consider all of them to be plus. Okay, we consider all of them to be plus. Now they are telling that it can be even, so we need to try to prove it at least one instance. Okay, let 5 of them, 1 2 3 4 5 5 of those terms, they have coefficient of 2, and the other 5 they do not have any coefficient. Yes, so I will assign, they are telling us that 5 of them are even and 5 of them are odd. I will assign all the odd numbers to those variables which have a coefficient of 2. For example, a, c, e, g and I, let them all be odd. Okay, then b, d, f, h and j, they will be even. Okay, and they have a coefficient of 2, so they will also become even, right? 2 into 1 2, 2 into 3 6, 2 into 5 10, 2 into 7 14, 2 into 9 18. So ultimately what you will have in this expression, you will have all even integers to be added up. So, and however many odd ultimately we will be having even 10 even integers to be added up, and however many even integers there be, if you add them, the resultant will be even. Okay, so we can imagine one instance where this resultant, it can be even. No, you can also imagine, you can also imagine an instance where it can not be even. It is okay, but the statement says can be. So if you can prove it in at least one instance, then it is true. So in this question, your statement 1 is true and statement 2 is also true. So what will your answer be? Our answer will be both 1 and 2. Okay, let's go to the next question. We came to your homework question. This question, it was asked in the 23 paper. 3 of the 5 positive integers p, q, r, s and t are even and 2 of them are odd. Consider the following. P plus q plus r minus s minus t is definitely even. 2p plus q plus 2r minus s plus t, it is definitely odd. Which of the above statements is or are correct? So evaluate these two statements based on the basic concept that you learnt in the previous questions and leave your answers in the comment section. We will discuss the answer to this in the next class. And now it's time to answer the previous class's homework question. This was the previous class's homework question. The topic was math based reasoning. There is some operation being happening between 7 and 9 and 9 and 10, and ultimately you get 8 to be the resultant. So, but this is not plus, this is not minus, this is not into, this is not divided by necessarily. It might be some of those operations, or it might be a completely new operation. We need to evaluate and we need to apply this for 23, 4 and 15. So 7, 9 and 10 they give you 8, 9, 11 and 30 they give you 5, 11, 17 and 21 they give you 13. So what is the value of 23, 4 and 15? Okay. Let's try addition first, because that is the simplest. 7 plus 9 plus 10, that would give you 10 plus 9, 19, 19 plus 7, that would give you 26, but we want 8. Okay. 9 plus 11 plus 30, that would be 50, but you want 5. 11 plus 17 plus 21, that will give you how much? 11 plus 27, that would be 28. 28 plus 21, that would give you 39. 11 plus 17, 28. 28 plus 21, 49. That will give you 49, but you want 13. Is there any way where you can derive 8 from 26 and 5 from 50 and 13 from 49? Yes, we learnt in the previous class that when this thing happens, we need to do some trial and error and see how to derive 8 from this expression, 5 from this expression and 13 from this expression. Okay. Here, if you have a bit of practice, it is easily obvious to you. What is it? 2 plus 6, that will give you 8, 5 plus 0, that will give you 5, and 4 plus 9, that will give you 13. So, they are adding those numbers and they are adding the digits of the resultant to get the new resultant. We will do the same for this expression also. 23 plus 4 plus 15, that would be how much? That would be 27 plus 15, so that will give you 27 plus 15, that will give you 42. What is the sum of 4 plus 2? 4 plus 2, that would be 6. So your answer would be option A, 6. Okay. Now, I hope that today's class, it was helpful to you. If you like the classes, do watch us regularly. We upload one episode every evening, and also share the YouTube link to this video with your friends through WhatsApp groups and Telegram groups. All the best, and most of all, a very happy studying.